In this video, we are going to go over our first main partial differential equation type, the parabolic differential equations. And the specific one that we are going to look at is the heat equation, which I have an example of here. U sub t is equal to 3 times u sub xx. U of x comma 0 is equal to x times pi minus x. And u of 0 comma t is equal to u of pi comma t, and that's equal to 0. And based upon this, we first need to separate a partial differential equation. So based on, not me writing over things, based on this u sub t, we have that first derivative, t prime. We're going to divide this though by 3, this coefficient, times t. That's going to be equal to, based on this term, we have our second derivative of x, divided by x. And this is going to be equal to negative lambda. And we could separate this. Right, we have two equations here. Based on the t variable, this is t prime over 3t is equal to negative lambda. We can multiply by 3t and add over lambda to get t prime plus 3t lambda is equal to 0. And then the same thing with x double prime over x is equal to negative lambda. Adding lambda, multiplying by x, we get x double prime plus lambda x is equal to 0. Now, based upon our boundary conditions, so this third line right here, let us start with u of 0 comma t. We could write this a bit. And actually, before writing, I should probably note, based upon what I wrote on here, that this is based upon, and actually, let me write that up here first before delving into that. This is based on u of x comma t being equal to x of x times t of t. So, based upon that, that's why we got these. And we could then now apply this boundary condition, so u of 0 comma t. This is, of course, equal to 0 based upon the condition, which that then means that we have x being 0 in here, so x of 0 times t of t. So that specifically, again, as I noted, means that x of 0 is going to be equal to 0, since we have t being some number. Likewise, we have u of pi comma t. That's also equal to 0, so this would be x of pi times t of t. And then, once again, this implies that x of pi is equal to 0. Again, based upon those boundary value conditions that we have. So then, we now have these two equations and these two conditions, which we have based upon this. So when it comes to solving this partial differential equation, we would get, for the eigenvalue, for lambda sub n, this is going to be equal to n squared. And this is our eigenvalues. The eigenfunctions are going to be x sub n of x is going to equal to sine of nx. And here, n is going to be equal to the values of 1, 2, 3, and so on. But based upon that then, we could utilize the value of this eigenvalue inside of our first equation here involving t. So this would be t prime. That's going to be equal to 3 times n squared t is equal to 0. And solving this would imply then that this implies that t sub n of t is equal to e to the negative 3n squared t. And that was just based upon our partial differential equations here. But based upon our eigenvalue, we have our general solution. We have our general solution. So in this case, that is going to be u of x comma t is going to be equal to the sum from n is equal to 1 to infinity of c sub n. C sub n times e to the negative 3n squared t times sine of nx. And based upon this other condition here, so this initial condition, we could utilize that. So this would be u of x comma 0. Again, we got x times pi minus x. We could set that equal to then the sum as n is equal to 1 to infinity of c sub n times sine of nx. And then this would be within the values of 0 and pi for this particular case. So then based upon that, and due to the fact that we have what is referred to here as a Fourier sine series. So let me just spell his name correctly. Very famous mathematician. The Fourier sine series. Because of that, which was based on this x times pi times x times pi minus x. Because of that, then we have the following, which I need more room to write. Then we are going to have, because of what we have here, c sub n is going to be equal to 2 over pi times the integral between 0 and pi of x times pi minus x times sine of nx dx. And this gives us a couple of nice values. We have 8 divided by pi n cubed. This is if n is odd. And 0 if n is even. So because of that, and actually let me rewrite that a little bit nicer just so it's easier to read there. 8 divided by pi times n cubed. Okay, so based upon that then, our equation then becomes u of x comma t is equal to 8 over pi times the sum as k goes from 1 to infinity of 1 over 2k minus 1 cubed times e to the negative 3 times 2k minus 1 squared times t times sine of 2k minus 1, since again we said this was odd up here, times x. And that is going to be our solution then to this particular heat equation. Look for the next video then based on the wave equation. Thank you.